Good morning, students. Let us discuss some of the questions on haloalkane and haloarene. See, read the first question. In the following compounds, least number of monochlorination is possible in. So, some alkanes are given. N-pentane, 2-methyl-butane. This is 2-methyl-propane, and this is neopentane or 2,2-dimethyl-propane. So, what is the question? In the following compound, least number of monochlorination products. So, one by one, if you analyze, this hydrogen you can remove one product. Suppose if you remove this hydrogen, it is the second product. If you remove this hydrogen, it is the third product. They are all position isomers. Do you agree? So, one hydrogen you have to remove. Which hydrogen? Secondary hydrogen is more possible to remove. So, this is possible, this is possible. Three products are possible. Here, this side, these are identical, right? One product, second product, third product, fourth product. Four are possible. Here, you can remove this hydrogen, tertiary hydrogen is more reactive, first priority. Next, these three are identical, right? So, only two products. Here, this carbon does not contain any hydrogen to substitute chlorine, but these four hydrogen are identical. So, only one monochlorination product is possible. So, answer must be D. So, I have explained all the possible products in all the four options. So, neopentane has, you can remove either one hydrogen to substitute chlorine, all are identical. So, this is the answer. Okay. Which is the correct increasing order of boiling point? A question on boiling point. One iodobutane, second one is one bromobutane, third one chlorobutane, fourth one only butane. See, only the halogen is different, and in one product there is no substitution. So I told you as molar mass increases, boiling point increases. When alkyl groups are same, what is the order of boiling point is iodide greater than bromide greater than chloride greater than fluoride. Okay. Now what is the order? Increasing order. This word is also very, very important. What do you mean by increasing order? Lowest boiling point should come first. See students, this is only butane. So this is a non-polar molecule. So this should be the lowest. So 4 less than 3, less than 2, less than 1. 4 less than 3, less than 2, less than 1. So option B must be the proper order because increasing order. If you select this order, this is not correct, but it is decreasing order. Is that correct? So you want increasing order, option B is correct. Third question. Among the following, the molecule with the highest dipole moment is. See in the synopsis I told you, CH3 up to CH3Cl, CH3Br and CH3I. There you are changing the halogen. What is the order I told you, remember? CH3Cl greater than CH3F greater than CH3Br greater than CH3I told you. But this question is having halogen atoms in different number. See, for this you should understand the structure of the molecule only. CH3Cl, I will write the structure. See this. This is knowledge of chemical bond. See the net dipole moment increases. But when you take the second option, dichloromethane, see what will happen? Cl, Cl, HH. Now the vector addition of two CH bonds are substituted. See this? By the two chlorine atoms, the addition product is substituted. Do you agree or not? Here the three vector product, addition of three vectors are in the direction of CCl bond. But here the two dipole moment of two CH bonds are divided with the three chlorine atoms. But when you come to chloroform, I will write it the other way because 3Cl are like this tetrahedral structure. Now you see the dipole moment of CH bond is divided between three CCl bonds. So here subtraction takes place. But what about CCl4? See, this is an identical molecule. So here what will happen is the dipole moment gets cancelled. So now this is 0. Non-polar molecule. Dipole moment gets cancelled. Dipole moment is 0. So highest is this, next this, next this. So suppose increasing order, this, then this, then this, then this. So according to this question, option A is having highest dipole moment. So whenever such questions are asked, you should go to the structure of the molecule, operate with the bond moments, then you will get the correct answer. Ethyl iodide, when heated with dry silver oxide, forms. Ethyl iodide, when heated with dry silver oxide, forms. So this question is one of the very important question because moist silver oxide you are understanding, but dry silver oxide. See, one general equation I will tell you: Rx with the KOH aqueous or moist silver oxide, same moist Ag2O. The product is alcohol. Alcohol. So I repeat, a haloalkane when treated with either aqueous potash or anyway or moist silver oxide, product is alcohol. But any haloalkane when treated with the dry silver oxide, remember, two molecules of it reacts and the product is ether. So please notice, this is one of the very important reaction. Dry silver oxide, it gives ether and not haloalkane. So here I have given an example. Ethyl iodide you are using. So same equation if you write CH3 CH2I, two molecules. So what is the product? Ag2O dry. So it should be CH3 CH2O CH2 CH3 dimethyl ether ethoxy ethane. Ethyl ether is there as the option. This is correct. Question number 5. Identify Z in the following. So I write the reaction C2H5I iodoethane alcoholic urine gives X, bromine maybe in CCl4 medium. I will write CCl4 medium. Y, KCl maybe alcoholic. Z. The question answer is the final answer is Z. Okay. This once again let us try to understand this C2H5, CH3, CH2I. Alcoholic KOH alcoholic. So all of you are familiar. Beta elimination. Beta elimination, simple elimination, and the product is PP. Do you agree? HIV will be eliminated by KOH because alcoholic KOH is elimination predominant. Aqueous KOH, nucleophilic substitution, SN2 predominant. So your option, now you have understood what is X. This is X. Now this is treated with bromine and CCl4. See, this is an addition reaction. So you must be knowing one important thing. When there will be addition, I will tell you all these things. For example, you can take chlorine also or bromine. See, chlorine or bromine in sunlight, this is free radical mechanism and substitution reaction. For example, hydrogen can be substituted by chlorine. The same chlorine in presence of some halogen carrier, this is substituted for electrophilic substitution to the aromatic ring. Is it correct? The same chlorine, when you use in an organic medium, you can carry this as electrophilic addition across the double bond. So remember, free radical substitution. This is electrophilic substitution. This is electrophilic addition. So here see the medium. Electrophilic addition should take place. What is the product? Addition across the double bond. So the product is CH2Br, CH2Br. 1,2-dibromoethane. This is, that's what? Y. So Y is this. Hello? Next. What is this? Alcoholic KCN. Z. Alcoholic KCN. So here one word I tell you, it should be excess here because Br and Br, both side it is there. Nucleophilic substitution. Remember, KCN gives free cyanide ion. The product is cyanide. Suppose if AgCN is there, I write both options, okay? So here I write alcoholic AgCN so that you can understand easily. Now what is the product? If you use alcoholic AgCN excess, the product is CH2CN, CH2CN. 1, 2, 3, 4. 1 comma butane, 1 comma 4. Dinitrile. This is the product. Suppose if you use AgCN, tell me what is the product? CH2, NC. See? So this is carbylamine. N-carbylamine. Or it is isocyanide. Isocyanide is the product. And this is what type of nucleophile? Impedant nucleophile. AgCN provides isocyanide. So one of the very, very important thing, whenever AgCN comes, silver cyanide comes in the alcoholic medium, your product is not cyanide, it is isocyanide. So what is the final answer now? CH2CN, CH2NC, wrong. Wrong. CH2 no. CH2Br, CH2CN no. CH2CN, CH2NC. No, none of the product is having. So I will write option D as this one. What is that? D, CH2CN, CH2Cl. So this is the right answer. Is it correct? CH2Cl correct, but this is CH2NC is written. If NC is written, it implies carbon nitrogen bond. There is no carbon nitrogen bond. You can open it and write here. See this is the bond. The planar carbon, sp hybridized carbon. Remember, Cl is like this, Cl you should understand. Okay, question number 5 is option D. Now, coming to question number 6. Which of the following undergoes nucleophilic substitution exclusively by SN1 mechanism? What are the products? Benzyl chloride. Okay, benzyl chloride. CH2Cl. Ethyl chloride. CH3CH2Cl. Isopropyl chloride. Yes. Chlorobenzene. See, SN1 and SN2. What is the things you are knowing? See, SN1 now, you know only this one. Tertiary greater than secondary greater than primary. Is it correct? Do you know why tertiary greater than secondary greater than primary? Tertiary has lot of, for example, tertiary butyl carbonate if you take. So it has a lot of steric effect. SN2 means simultaneously leaving group and incoming group should exist, which cannot happen because of steric effect. Okay. But here, tertiary is not there. Secondary is there. It has both the possibility. It may go by SN2, it may go by SN1. So both are probable. Now then, other two products are, one is a benzyl chloride and other one is a chlorobenzene, which is a aryl halide. Now, this is very easy to understand. This is a primary halide, exclusively SN2. But question is exclusively SN1. This is also, because it has two possibilities, you cannot take this. Then which is exclusively SN1? See, when chlorine is directly linked to the aromatic ring, two cases I will take. Vinyl halide, sp2 hybridized carbon, and then vinyl halide and aryl halide when sp2 hybridized carbon. Partial double bond character is generated. Correct? Partial double bond character is generated due to resonance. So these two, vinyl and aryl, are least reactive. They are not undergoing nucleophilic substitution in ordinary condition. So that is why this also is deleted. We cannot. Then what is the answer is CH2Cl. Okay. If CH2Cl, how it can undergo by SN1 path? Because it is primary, no? Primary should undergo by SN2. But please note this. Here, the carbocation formed by the loss of Cl minus is stabilized by resonance. When the carbocation is stabilized by resonance. Another example I will take. CH2 double bond CH, CH2Cl. This is allyl chloride. So in allyl, even though it is primary, the resultant carbocation is stabilized plus charge comes to this place. So both benzyl and allyl, in spite of having primary halogen atoms, undergo exclusively by S and 1 mechanism. This is the information here. Then answer is benzyl chloride. Is it okay? Next. Question number 7. In the following sequence of reaction, the end product C is, okay, let us try. CH3Br, KCN. KCN, if you use, it is CH3Cn. Just now I have told you. Similar question. CH3Cn. Okay, H3O plus. See students, in the later part of the learning of organic chemistry, this will appear. Hydrolysis of H3O plus in the sense what? H2OH plus. Is it correct? Hydrolysis of cyanide. Hydrolysis of cyanide gives COH. It's not this. Cyanide on hydrolysis gives what? Cyanide on hydrolysis gives COH. One of the very much required knowledge in organic chemistry. So COH is the product. Then lithium aluminium hydride. This is a method of preparation of alcohols. This is related to alcohols chapter. That is why if I start teaching you alcohol, phenol, ether or aldehydes, ketones, carboxylic acid, once again I am repeating all starting from hydrocarbons of first PUC. Everything will come, especially this type of sequence A, B, C, A, X, Y, Z, etc. They are all going to repeat. Such questions are very much favorable. So this is the reduction. Lithium aluminum hydride is the most potential reducing agent, best reducing agent. The product is CH3, CH2OH. Ethanol is the final product. Is it okay? Ethanol is the reduced product of which one? This one, ethanoic acid. The answer is ethanol, option A. The increasing, 8th question, the increasing order of reactivity of halogen atom. The increasing order of reactivity of halogen atom for the following compound. I have already discussed for the following: vinyl chloride, chlorobenzene, and vinyl chloride, chloroethane, CH3, CH2, Cl. See, this is sp3 hybridized, this is sp2 hybridized, this is sp2 hybridized. So what is the order of reactivity? Here, if at all you form carbocation and a form a carbocation here, this carbocation is least stable. Vinyl carbocation is least stable. Next, vinyl carbocation also less stable compared to this one. It is better, but this is most stable. Hyperconjugation stability. Hyperconjugation stability due to these three hydrogens. Is it correct? Stabilized by hyperconjugation. So that is why this is number one reactive sp3 hybridized. Out of these two, both are sp2 hybridized. However, vinyl carbocation is less stable than phenyl carbocation. So that is what is the order of reactivity? Which order is asked here? Increasing order. That means lowest should come here. Vinyl first, next to phenyl, and last one is ethyl. So order is increasing, correct? Increasing means vinyl first. 1 less than 3 less than 2. Yeah, option B is correct. Is it correct? Option A. Question number 9. An alkyl chloride a dry ether followed by treatment with ethanol gives 2-methyl butane. The alkyl chloride is. So you go back, the reverse reaction, Grignard reaction, they have asked. Some alkyl chloride is there, they are in the option. What is alkyl chloride? They are in the option. That alkyl chloride is treated with magnesium metal, Grignard reaction, in dry ether. And then it is treated with ethanol. And the final product is this one. CH3, CH3, CH2, CH3. Do you agree? 2-methyl butane. Is this correct? 2, 1, 2, 3, 4. 2-methyl butane. Now my question is, to get 2-methyl butane, when C2H5OH is used, very very important one point I will tell you. You read this question, coming to this, concentrate on this. RMGX, when treated with any of the protonating species, any of the protonating species, water or HCl, any acid, or even ammonia, or even acetic acid, or C2H5OH, ethanol also provides H+, or even alkyne having acidic hydrogen. Hydrocarbon chapter you understood. Alkynes are having acidic hydrogen. Final product is RH, alkane. So ethanol is used here means ethanol supplies what? Supplies hydrogen. Then what may be the probable structure for that Grignard reagent? Because ethanol will not add anything except hydrogen, ethoxide ion plus H+. When you see the options, because this is the final product, when you see the option, I always feel this is the best option, because if I go for this Grignard reagent, CH3, CH3, right, MgBr, CH2, CH3. If this is the Grignard reagent, try to understand. So C2H5OH provides for hydrogen, then this will become CH. Then if you go back further, how this is going to be obtained? Mg and ether, and that alkyl halide was CH3, CH3, Cl, maybe chloride of Cl, CH2, CH3. So now once again go in this direction, Cl, Mg ether, we are, I have done wrong, MgCl, correct? MgCl, then protonating species, this or any other thing. I told you no, how long? Even alkynes are having acidic hydrogen, triple bond content. Don't try to add carbon, it is C minus H plus. Here Mg plus C minus, H plus will come here, C minus. And the CH. Correct time noting. Learn this reaction very carefully. Proton here, ethanol andaga. Don't try to add C2H5 and all. It provides hydrogen for Grignard reagent. Adike Grignard reagents are always preserved in ether, prepared in ether, reacts in ether, always kept in ether. If it contacts with any amount of air, it becomes alkane. Immediately alkane. Okay, answer is A. The last question. Reaction of toluene with excess of chlorine in the presence of sunlight gives reaction of Tolby. Again, one of the very important reaction to understand. Here, so many things are there to understand here. Tolby. Is this correct? Tolby. So, let me tell you some of the reactions. Chlorine, sunlight. Same Tolby. Chlorine, ferric chloride, absence of sunlight. So, these are all going to be counted. Same chlorine, electrophilic addition, Cl2, CCl4. These are making lot of differences. Now here, chlorine and sunlight they are telling. Chlorine and sunlight means you have to go for free radical substitution like methane. And one more word is written there, excess. Read this. Excess of chlorine. What should happen? Go on substituting this. CHCl, CH2, Cl. Benzyl chloride. Once again chlorine, because excess chlorine is there, you can remove all the hydrogen. So now the product is CHCl2, benzyl chloride. See the common name? Benzyl, benzaldehyde, benzyl chloride. Once again you can substitute because still a hydrogen is there. Final product is CCl3, benzo trichloride. But suppose if you use ferric chloride and orthopara, you get this is minor product and this is major product. Chlorine in halogen carrier, ferric chloride. Free radical substitution. Electrophilic substitution gives orthopara. Electrophilic addition gives this will not be affected. You have to operate the aromatic rings Cl. Like this. Electrophilic addition you have to do by opening the double bonds. So that is why I told you what is the condition. This is most important thing. Whether it is chlorine in sunlight is set, whether it is chlorine in presence of halogen carrier is set, or whether it is chlorine in presence of a non-polar solvent is there. So this set all very much counts. So answer is benzyl chloride wrong, benzyl chloride wrong, benzo trichloride is correct. Excess. This is wrong. Okay. See the next question. Question number 11. In which of the following CCl bond ionization gives most stable carbocation? So it is given in the bond line form. So what is the first one is, see this C, I write in this fashion, Cl, CH3, CH3, CH3. Is this correct? And what is the carbocation? If you ionize this, it is CH3, C plus CH3, CH3. Tertiary butyl carbocation. It is hyperconjugation stabilized by 3 plus 3, 9 hydrogen. So it is most stable. One structure I write, hyperconjugation. So you can know what resonance. So what will happen? This will ionize as H plus and this will acquire C minus, and this is how it is going to be stabilized. Resultant structure CH3, C double bond, CH2, and that H plus will remain here only. So this is one structure. Similarly, next hydrogen, these 3 hydrogen. So there are 9 hydrogens. When you come to benzyl chloride, this is stabilized by benzyl carbocation, that is CH2. Okay, resonance effect. Here, this is a secondary carbocation CH3CH stabilized by hyperconjugation due to 6 hydrogen. And this is ethyl CH2Cl, and here there is CH2Cl, CH2, one more CH2. Here NO2 is not this, it's a electron withdrawing group. Suppose if at all a carbocation is formed, CH2 plus CH2 NO2 withdrawing group is there. This is least stable because electron density is further increased here. Instead of withdrawing nature, it is not stabilized at all. So what is least stable? This one. Which is most stable? Tertiary. So order of stability I write tertiary, greater than benzyl, greater than secondary, greater than primary. This is the order of stability of carbocations. Tertiary greater than secondary, greater than primary, you are knowing now. Now benzyl comes, it is less stable than tertiary, but more stable than secondary and all. Even allyl is more stable than secondary. Then tell me the correct order. Tertiary greater than benzyl, greater than allyl. Tertiary greater than benzyl, greater than allyl, greater than secondary, greater than primary. So answer is what now? A. The product of the following reaction. So there is a reaction. Look at this. Toluene is the principal group. Para place there is anode. Now you must be knowing that during domination, electrophilic substitution, because there is a halogen carrier. Orthopara-directing nature, meta-directing nature, deactivating. You must know what are orthopara-directing group, what are meta-directing group. Halogens, alkyl groups, OH, NH2, they are all orthopara-directing and activating. Of course, halogen is deactivating but orthopara-directing. But NO2 group is highly deactivating and meta-directing. So now you have to select a structure. You don't watch the answer. You can understand easily. See, you have to select such a structure that meta to this and orthopara to this. So meta to this and orthopara to this. Here if you write, impossible. This is the better place. Okay? Because with respect to this ortho, with respect to this meta. This should be the answer. Here or here is. What's the answer? This cannot be, because NO2 position cannot change. This cannot be. NO2 position is changed. This is correct. This is not, because here meta with respect to CH3 and ortho with respect to this, which is not correct. D is the correct answer. Okay. So question number 30. Question number 30. Which of the following is a primary halide? Which of the following is a primary halide? Isopropyl iodide. See, common names are given. Sometimes common names when it is given, you will not be able to understand which is primary and which is secondary. And whenever question is asked like that, you should write a structure. Isopropyl iodide. Say this CH3, CHI, CH3. This is secondary. Correct now? Secondary butyl iodide. CH3, CH2, CH2, CH3. Secondary butyl. See this. This is secondary butyl iodide. Again it is secondary. Tertiary butyl bromide. See this CH3CBr. You are familiar with this compound. This is a tertiary halide. Then what about the last one? Neohexyl chloride. What is a neohexyl? See what is neo? This is neo. CH3, 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 CH3. Neohexyl you want? CH2, CH3. Neohexyl. This is a neo structure. Now you cannot place any halogen here. So neohexyl means either of these you have to have CH2Cl. This is neohexyl chloride or CH2Cl or CH2Cl. This is primary. Adjacent to primary there is a quaternary carbon, but halogen atom will link to primary. So you must be knowing what is primary, CH2X, what is secondary, CHX, what is tertiary, CX. Okay. Question number 40. Tertiary butyl bromide. So neohexyl is correct here. Tertiary butyl bromide, when treated with sodium ethoxide, produces predominantly tertiary butyl bromide, when treated with sodium ethoxide, produces predominantly tertiary butyl bromide. See, sodium ethoxide, what do you call? Is it a nucleophile or a base? Sodium ethoxide is more base than a nucleophile. Suppose I tell you Williamson's intersynthesis. It should be discussed under ether chapter, but still I tell you, if you use a haloalkane which is primary and CH3, CH2ONA, you get ether. Condition in Williamson ether synthesis is when heated with sodium ethoxide, sodium alkoxide, haloalkane must be primary, and it is written in the textbook under the ether preparation chapter. If the haloalkane is tertiary, then nucleophilic substitution is not possible. The product must be sodium ethoxide. Product must be 100% alkene, they are telling. So that is why here it should act as a base, and it is not Williamson ether synthesis. It should extract a proton. So if it extracts a proton to HBr, because it is a base, the product is CH3, C double bond, CH2, CH3, 2-methyl propene, right? 2-methyl propene, option C is correct. 15th question. Which of the following produces pure alkyl halide when heated with alcohols? See, I have already told you under synopsis. Darjan's method I told you. Darjan's method is what? Halogen chloride when heated with alcohol produces alkyl chloride. Byproducts are gases. That is why this is the best method. But you see, PCl5 gives POCl3, which is a liquid. You have to separate it. Pure will not get. Chlorine will not react with alcohol. Chlorine will not react with alcohol. So, don't think that chlorination is done with chlorine all the time. With alcohol, it will not react. This is impossible. Not possible. Here, again, it gives like 3PO3, phosphorus acid as a byproduct. So, that is why answer must be D. So, with this, I have discussed some of the questions on haloalkane and halogen. Definitely you have to work out, these are reference questions. Definitely you have to work out more questions to be thorough in this organic chemistry first chapter. Thank you.